You've seen the job postings: AI engineer at a bank, AI engineer at a startup, AI engineer at a hospital, AI engineer at a grocery chain. It is everywhere, and the salaries are absurd. But here's the thing: if you ask most people what an AI engineer actually does, the answer gets vague really fast. They work with AI, they build AI things. It's like data science but different, and it gets even more confusing when you try to figure out how it's different from an ML engineer. So that's what this episode is. No vague definitions. Two roles, totally different jobs. Let's fix that. To understand the AI engineer role, you need about 60 seconds of history. Because honestly, this job didn't exist 5 years ago. For a long time, if you wanted to work in AI, you were in one world: machine learning research, deep math, specialist teams, a strong academic background. That was the ML engineer. Then in late 2022, ChatGPT launched and everything changed. Suddenly, frontier AI wasn't locked inside research labs anymore. It was available with a single API call. And companies realized something: we need people who know how to build with this, not train it. That's exactly where the AI engineer role was born. Let's start with the ML engineer, because understanding this makes the AI engineer role so much clearer by contrast. An ML engineer's core job is to create the model itself. Step 1: Data. Everything starts here: collecting it, cleaning it, labeling it, so a model can actually learn from it. Bad data, bad model. Simple as that. For Ola's search model, that's millions of historical rides. Live demand, available drivers, weather, how things played out the last time conditions looked like this. Step 2: Architecture. You choose or design the model's structure. How many layers, what kind, how inputs flow through it. For an LLM, this is an entire research discipline on its own. Step 3: Training. And this is where the real cost hits. You feed data through the model, see how wrong it is, and nudge its weights to make it a little less wrong. Millions, sometimes billions of times. For a large model that runs on thousands of GPUs for months and costs hundreds of millions of dollars. Step 4: Evaluate and tune. Is it accurate? Does it generalize to things it's never seen? Is it biased anywhere? Engineers run experiment after experiment and sometimes just go get more data. Step 5: Deploy and monitor. The model goes live, but the story doesn't end there. Models drift as the real world changes, so the ML team keeps watching it long after launch. So who actually does this? Mostly big tech AI teams, research labs, and enterprises training their own models. Startups almost never train from scratch. It's deep specialized work and it takes years to get good at. Now, the AI engineer. Same broad world, completely different job. Their core work is building products and systems using models that already exist. Step 1: Choose the right model. GPT-4, Claude, Gemini, each with different costs, latency, and context windows. The AI engineer weighs all of that and makes the call. Step 2: Design the system around it. Because one model call is almost never a product on its own. You have to think through how a question reaches the model and what happens when it gets something wrong. Retrieval, routing logic, fallback handling, caching. That's the scaffolding an AI engineer builds around the model. Step 3: Prompt and context engineering. How you talk to the model shapes everything it does. The system prompt, the examples you give it, how you structure what it sees. A badly written prompt on a great model can lose to a great prompt on a mediocre one. This is real engineering work, not an afterthought. Step 4: Build the product layer. The AI call is just one piece. The engineer wires it into the UI, the API, the database, the whole product around it. Step 5: Evaluate. How do you actually know your system is working? You measure it. Test sets, automated judges, real user feedback. Step 6. Ship and monitor. Latency, cost, error rates, hallucination rates. The AI engineer watches all of it and keeps tuning. So what do you actually need? Software engineering fundamentals, LLM APIs, prompt engineering, RAG, evaluation, a real buildable skill set. What you don't need: advanced math, training frameworks, MLOps infrastructure. That's a different job entirely. Let's make this concrete with something most of you use. Ola. That moment the price jumps and it says fares are higher due to demand. That sounds like a random tax. It isn't. The ML engineering layer, a search model trained on years of rates, live requests, available drivers, time of day, nearby events, historical demand, weather, area congestion, all of it feeding one model. All of that produces a search multiplier. Years of work. The ML team owns it and nobody else touches it. The pipeline behind it: collect the data, clean and label it, train the model, evaluate it, deploy it as an API. A living system, continuously retrained. Now the AI engineering layer. 4 more signals combined here. The search model's own API, a regulatory price cap, an active promo code, the radar's fare history. The AI engineer wrote the logic that decides when to trust the multiplier, when to cap it, when to just show a flat price instead. And then the edge cases. What if the search model is down? Fall back to a fixed cap. What if driver location data goes stale? Use the last known count. The product can't just break. Same app, 2 completely different disciplines. The ML team makes the prediction accurate. The AI engineering team makes the price actually make sense. Let's do a second one. LinkedIn, the jobs for you feed most job seekers check daily. A senior AI engineer role, 92% match. The ML layer, a matching model trained on billions of interactions. Your skills, your connections, similar profiles, the posting's title and seniority and location. It's an embedding and ranking model, matching your profile and a job posting in the same mathematical space. Years of training. The ML team owns it. The AI engineering layer, a great match score means nothing if the feed feels repetitive or ignores the filters you've already set. So there's a feedback loop. You apply, strong positive signal. You save, medium signal. You tap not interested. That goes straight back into the next training run. Same product, same split. The ML team makes the match accurate. The AI engineering team makes the feed actually usable. Real talk for a second. These lines aren't always clean in the real world. There are a few places where the roles genuinely blur. Fine-tuning. If you take an existing model and train it further on your own data, you're technically touching weights. That's closer to ML engineering. But plenty of AI engineers do this, especially at startups, because the bar is so much lower than training from scratch. Evaluations are their own blurry spot too. Some engineers specialize entirely in measuring whether an AI system actually works, sitting right between both worlds. And at an early stage startup, one person often does everything. Picks the model, builds the system, fine-tunes it, ships it, monitors it. The role boundaries just collapse. The honest point is, these aren't castes, they're a spectrum. Most people watching this, you're more naturally suited to and more urgently needed as AI engineers. Let me put the skills side by side, so this is completely explicit. Foundation. The ML engineer needs deep mathematics. The AI engineer needs solid software engineering fundamentals, language and tools, PyTorch and TensorFlow on one side, Python and REST APIs on the other. Core skill, training and evaluating models versus prompt and context engineering. Data layer, data engineering pipelines versus RAG and vector databases. Infrastructure, MLOps and distributed training versus AI frameworks like LangChain. And how you measure success, research metrics on one side, evaluation pipelines on the other. And here's the liberating part. None of the ML column is required to be a great AI engineer. You can genuinely start today. ML engineering. Fewer roles, a much higher bar. These jobs mostly live at Google, Meta, OpenAI, Anthropic, and a handful of large enterprises. AI engineering, on the other hand, is exploding everywhere. Banks, hospitals, e-commerce, logistics, every single startup you can think of. If you're a developer today, this is genuinely the most direct path into the AI industry. The skills stack directly on what you already know. And the salary reality in India, AI engineering roles run 25 to 60 lakhs for mid-level, higher at the senior end. Globally, even more. For both roles, honestly, demand far exceeds supply right now. You don't need to understand how GPT-4 was trained to build something with it. You just need to understand how to use it well, reliably, and for the right problems. That's exactly what this season covers. Episode 5 is next: pre trained models and why you almost never train from scratch. Subscribe and stay with us. There's a lot more coming this season.